Hello, everybody. So last week we were working on sort of a big GUI project. Well, some people already turned that in. I kind of wanted to go ahead and finish up the one in class because there was something I wanted to use it to make a point. Actually, 2 points that are included in there. And yeah, my original plan for this evening involved making lots of points. But then one of them was just a story that happened years ago. I ended up putting that on a video and sending out the link. Check that out if you haven't watched it yet. I sent out the announcement the other day. I was planning on telling that in class, but then when I started jotting down notes, I was like, wait, this is going to turn into a really long story when I start talking. That's going to eat up a lot of class time, and this is kind of a short class. So I think I'll just make a video, and it's just a story that relates to software development in general from a few years back. The gist of it was on a piece of software that I got working, but it was 9 or 10 months after the release before I was able to figure out why it worked. And talking about that sort of thing some. But there was a couple other points that I wanted to make in class that wouldn't involve along with the stories that I very well could drift out on. So I decided to make that one a video. And then the other 2 points I wanted to express were kind of in finishing up that project that we were looking at. I know a couple people have already turned it in. Do I have any special notes here? Did not make anything on the special announcement or anything. So I guess we'll jump right into the example and kind of finish that out. Let's finish up the first version of that, which is one of the points I wanted to express this. So I go ahead and share my screen and start up Spider. Pretty sure the files are still here. And I'm almost caught up on grading, I think. There's like a couple things left that I'd send out emails about, and then things turned in today. But otherwise, I did finally get caught back up on grading. I'd gotten behind on that, as you all probably noticed. Let's see if I go over to files, documents. Okay, looks like stuff's still here. This one? Yeah, I think this was it. Okay, this is the one where we started working on in class. Just a reminder about where we were. It was class, so there was a lot of talking along with writing the code. So it took a minute to get the stuff together, but we put one menu item in this. The homework assignment had a couple more, but really at that point, it's a copy and paste thing. And again, one thing in the toolbar, and there's a status bar down the bottom, but when we click our button, nothing happens. You can see in the background an error message happens. We need to fix that. And then when we were putting this together, my thought was, okay, maybe we can give each employee their own tab. Because, well, it's something that's not a stripped down example. That would be very useful because we probably have lots of things we want to do about each particular employee, right? You have different vacation days, sick days, the number of sick days accumulated to keep track of, requests for days off, personal information, and there's a lot of stuff that would be separated per employee. So it seemed like a reasonable way to maybe give each employee their own tab. And we got it set up, but we didn't quite get it working. So the first thing we need to do is make this method work. And perhaps use that status, update that status bar so that shows. and get the things on there working before taking the next step. There was one other thing that I mentioned the other day, but then didn't change it here in order to remind you about it one more time. So this is all working. We just ran it, so it worked fine. The library we were using for our class example was stored somewhere else. So we have to go to that file and look for it. So I do that. Just import the library that allows us access to the operating system we're working on, which that contains a variable called path, which is actually a list of all the directories where it's going to go look for Python scripts to see if it can find the one we want to use. So we added another one at the beginning, and I typed the address in explicitly. Said, okay, go to the C drive, user folder, all of that stuff. You can see it on screen there. And that worked fine here. Then when we looked at the native stuff and opened the same code on the Mac, that caused a problem, right? Because on the Mac, there's a completely different directory structure. You can't even use a Windows directory structure there. So whenever you're setting things up like that, I always wanted to use absolute. You guys want to use relative addressing. So this is what's called absolute addressing. What we have here, the file is absolutely stored in this folder, this particular folder. But we're writing software to probably with the intention of running on somebody else's machine, which means they're going to have a different directory structure. So those absolute paths can be problematic. Right? It would pass all the tests on our machine, but it's not going to work on anybody else's machine. It wouldn't even get all the way through the path unless they happen to have the same user profile name that my Windows 10 machine does here, which it just grabbed the first few letters from my email address. Isn't even really my entire name or anything. So relative addressing is usually a better idea. So instead of saying exactly where that file is, or the folder we want to look at, we want to say where it is compared to where we're at. So if it's in the same folder, we can just throw the name on there. That's what we usually do in classroom examples to keep the example somewhat simple. If it's in a subfolder, we can just put a slash at the beginning to indicate go into this other folder, or if it's in a, sorry, not at the beginning, at the end, because this other folder would be in the same directory we're in, and then slash means go into it, and then there's some more stuff in the go wherever from inside there. Or the symbol dot dot means the folder we are currently in, and dot means to go up a level. So usually we want to go up a level. Well, that's where we need to go for this one. Go up a level and then go into another folder called PyOffice. So hopefully we go up one level, the computer will see a file called PyOffice, which over here, go up one level. That's where we came from. And then right over here, I guess like a parallel folder, is the one we want to get to. And dot only means go up one level. So if we had to go up two levels, it'd be like dot slash, oops, dot slash, go up two levels and look for another folder called PyOffice. So want to be careful with where we look for stuff, or later when we talk about installers and get what we do when we release software, it might be useful to keep in mind that you do have control over where the installer puts things. Like we're going to put stuff in on a Windows machine in the folders programs or programs x86. The two things where the user doesn't have write access, so they can't change the software we put on their computer. So we might want to put the directory for those, but those we can handle with absolute address. usually you want to keep track of all of your stuff and do it relative to the current script. Obviously, in the same folders, the easiest one. That's why we do that in classroom examples all the time, and textbook examples, to clear out clutter for something that is clearly intended to be reference material. But software growth is going to grow large very, very quickly, and we'll end up with lots of files, and having them all in the same folder is kind of disorganized. And we only have one image here, but if we had an entire toolbar full of images, we probably want those in a separate folder. That's like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17. Oh, that's a reuse of the other one. 17. So the toolbar here in Spider has 17 images it needs. So if that was in the same folder as all the scripts controlling the IDE, that's more stuff adding to the clutter, making it harder to find in each particular folder. So organization goes a long way, and you want to refer to stuff relative to where the current script is. Server refactor, which means if you start reorganizing it, you need to be very careful. We're going to talk about that in week 5, I think. About refactor. The term is refactoring, cleaning up, reorganizing, right? Often while we're getting a program working, we end up with some extra stuff in there. Redundancies and things that we'll later realize weren't quite necessary as we think back over what it took to make the program work. So we want to clean it up and organize it, reorganize it after it works. That's not part of debugging. That's what I'll use people at first. Refactoring isn't for debugging. We refactor programs that have already been debugged, and there shouldn't be any bugs left when we get done. We're just cleaning it up, organizing it, renaming things, and making the code look nice once we get it working. So we kind of got things weren't quite working the same once we added that other stuff in. For example, where our hours come from. This was just put in temporarily, so I'm going to comment that out. Just another thing, when you're developing your program, never delete immediately. Always comment things out so that you can get back to the last thing that worked. And sometimes we're trying to do something, we might have to take a couple steps back and try again. And if you just delete things or completely change it, it may be a bit problematic to get back to the last thing that worked. So always comment stuff out, and then once the new stuff works, then delete it. Which is something I learned over the years from not doing that. So perhaps ignoring that advice or keeping that advice in the back of your mind until you've done it a few times might help you see the importance of that. So we made different inputs on each one. Where did I put that? There it is. So the Bob tab for that employee has its own entry box. And that's where we're going to input Bob's hours. And then a different one for Sally's. So when we call our method, which happens up here and in several different places, we want to pass that in. That way we don't have to write different methods or a big selection structure that to choose from it, because when we click something, it'll run immediately. So that's the initial thought. Then as I look at this code, it's like, okay, where do I put that in? Stare and stare. And I go, actually, that might be hard. Might actually need a selection structure this time to determine whose whose code we're calculating. So we could hit Bob's hours, or Sally's hours, or Becky's hours. We enter each one separately. But then our buttons are up here, or up here. We had an input box, or just called that whenever there was a change. That might work. So, along with clicking the buttons, we also do just changes immediately, right? Which y'all know the process. You're probably not going to memorize everything, right? If I ask you tomorrow or Thursday, you're probably going to remember a whole bunch of stuff you did on the current assignment. But then 2 weeks from now, you'll have to think back about a lot of it, and maybe even look back at some of it, which is often a good idea as you progress further and further. Make sure you keep all your old files around, even unfinished projects. I have a huge folder, huge folders of things that were finished and unfinished both. That way, if I need to look something back up, I can go look at the one written in my own style that was typed up after I understood the process and not dig back through all the tutorials to find it. But at first, I'm probably going to go look it up, right? Run method, enter key, and TK enter. So you can do something like that, right? And start looking at that, and it's like, oh wait, that's one of the things that was asked, that was extra credit points on the GUI assignment, and I said 320 class, right? It's like, oh, just keyboard binding to the event key. I know how to do that. Use bind, key, handler, yeah, just want the enter key. Because the only question is what is the symbol for enter key in particular? And you all know this. Well, the return key. There's a lot of different things you call that key, right? And it is going to be called different things in different libraries. So that's the process, but you do want to try to minimize that process. That was what the point of the story that I just put on video is. Yes, we can Google our way to a software development degree like that, but there's something lacking. My general policy is always try 3 times before doing that. I'll take a guess and then try something. If that didn't, take another guess, try that. If I don't get it in 3 guesses, then I go look it up. And usually on the first time, I try to avoid looking thoroughly, even to the point that I could fully copy and paste something. Just the first time is looking up a hint, so that I can take a couple more guesses and look further. But other times, time is an issue. So we have that input box. So maybe one way to do this would be just pass those in from the enter key. Or run the method and start going through options like this. So that would work. Then would that cause a problem when we go run the method? And start asking questions like that and kind of follow it through. It can be good to think ahead before you type. Like, okay, so if I hit the enter key, I can pass the box that has focus when that's entered. I can check all of them. That seems like it would work, but how's it going to tie in? Remember our criticisms for event-driven programming. Overly complex, difficult to extend. So we need to extend this now. I want to extend the functionality to type in a number and hit enter and get that person's hours. And we kind of go back and forth, trying to describe the process without and stretch it out, because you all know this is a long process, right? but not too far. I already have something in mind. So enter key, bring in the one that currently has focus, that would work. Oh, but then that's gonna give us a problem with the buttons. Because when we click on a button, the thing's not gonna have focus anymore. Which brings us back to a big long if statement. It's like, well, the if statement is what I want to avoid. Because in this case, our stripped down classroom example, we only have 3. That's not a bad if statement. But a company that only had 3 employees probably wouldn't need software to handle their payroll, right? They could almost do that. With only 3 employees, they could do the payroll with a pocket calculator without too much difficulty. Which means any reasonable sized company, a big one would be a problem. What other options? And maybe go back, sometimes thinking will lead to looking at it again. So I want to be able to type a number and hit enter, and then that shows up here. Or go over here, type a number and hit enter, and that shows up. And then there's something to notice here. There's 3 of them. And here where it's laid out with tabs, they're completely separated. If I hit the enter key while looking at Bob's tab, I can't see the other ones. If I enter Bob's numbers and come up and hit the button, I can't see what's going on in the other tabs. So the question to ask my is there anything to really stop me from calculating all of them right here? I don't think there would be a problem. Until it got really, really big. That wouldn't be a big deal. And if you were working for a big company and it's like, okay, here's the entire database of 10,000 employees to run payroll for, the person that clicks that button probably expects to click the button and walk away. They want to click the button 10,000 times. So why not just run all of them at once? That might not be too bad. Enter everybody's hours and then just call the method when we're ready. Then we have everybody's hours as a list. So I'm going to put that in another method. I'll call it get hours. Don't think we need anything special, and I'll compare and define it before we use it. Actually, no, I'll just do it right here. There's only 3 in this example. If it got big, it might be good to separate that off. But we can just check each every label we have and pull the stuff out of that. Could be one option for doing it, but that general back and forth is what you're going to think about. So I'll just go ahead and do that here. So let's say Bob hours equals LBL, txt Bob dot get Becky hours equals txt Becky. And then yeah, that other thing I was talking about generalizing it, that would be handled a little bit different, but the process of asking questions would be very similar. But to save time, we're going to talk about generalization all at once and just kind of put together some stuff in this that would work. This is the first point I want to make before we relate to this. So this was the first thing I thought of that would work for all of these. As I look at this, well, those are all going to be the same. So I'm going to put that in a list instead. Employee hours equals a blank list. So let's say this. 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 That way I grab the hours out of each one of them. And then can loop through and make sure they're numbers. That a number was entered into that box, because they might give us something that's not a number, right? So for E and employee hours, if not is number, E. I do the is number backwards. Would that be E dot is number? After I looked at that, I think I did that backwards because I have a bad habit of doing that because of another language I'm used to typing in. But this is a Python class. So, that's another thing. I often point that out when helping people with math. But if you can often make the same mistake, make sure you double check it every time that shows up. Like I often do is number and then pass something in and it's backwards. But maybe it needs to be the other way. E something dot is number. Check if that's a number. So if it's not a number, put a 0 there. That'll work. Then we have numbers for all of them. Else cast it to a number. Which I think takes care of this line. That was grabbing the text box from the early example and converting it into a number. So now we'll just put all the text boxes in the list, loop through there. If it's not a number, put a 0 there. But if it is a number, we can just cast it. I wanted to make sure and point out that method too. I think I put the comments in a recent homework assignment for like half people's in here's classes. That one might have been overlooked. We have methods to check if things are numbered, if things are numbers or alphabetic or arbitrary characters. I saw some really great work. Y'all came up with some very, very good algorithms to search through and figure that out. But there's already those algorithms have already been implemented in Python. That's a very common thing. And that's what I originally meant for you to do in that homework, is use the built-in ones. I guess it hadn't been mentioned in class yet. Is number, is alpha. That's the ones we use most often. Usually anything more complicated than that, and I'll jump into regular expressions. So employee, I don't think we need that anymore either. That's which one? Oh, that was something different. I think that's gone. So it is instance. Choosing an employee might be a problem here. I didn't really think ahead too much on this, on how it was going to need modified. So I wanted to go through the whole process here in class and talk about that. So trying to think back to what I did a week ago. And what was originally we entered a number, everybody's hours were the same. So now we get the numbers. Oh, we need to do this for the entire list, don't we? I'll do it as parallel arrays. So we have employees. So for E and employees. So that way we'll get through each one. We'll do all this. Oh, this needs to be hours. So looking at that, does that make sense? I didn't take a head on it because I wanted to go through the process in class. I didn't think ahead much on it. I do often think about what's going to happen in class, even when I'm trying to do the unprepared ones. So we're going to grab all of those text boxes, loop through, see if the thing there is in hours, and oh, I think I want to do these in the same order. Yeah, so that would be this one. Needs to go over here. Because looking up here, it goes Bob, Sally, Becky. So we go Bob, Sally, Becky here. Then I just want to walk through once so I can hit both arrays. And for whatever the length of employees is. We'll do that. And then, after we get our hours, we'll take the employees array for whatever our current index is. So thinking it through there, I was trying to talk along the way. Just what I did makes sense. Does anybody have questions about that? Do you see anything that could go better there? You probably have a bunch of ideas that could go better there, right? So we set an array up in the same order as our employees are. So we'll walk through, just look through either one. Oh, well, I guess I need this now because that's not E. If hours, the current index is numeric, or if it's not a number, put a 0 there. Otherwise, convert it to a number, which should probably be a floating point number. Then we'll check and see if the current employee we're looking at is a manager. And if they are, they just get that constant 40 hours for the breakdown. Otherwise, we'll calculate gross pay. And then we can jump through and grab that gross pay. But we need to spit it back out somewhere. So there's 3 different labels. And I've already noticed in one spot that could be cleared up a whole lot. Because here we're making a string of those text boxes. So maybe we could just spit it out there. I'll just spit it back out on for each one. So I think I want to label a list of outputs in the same order. That way that logic follows suit and it goes through everything at once. I don't know, I don't have a good name, but I'll call it imp output. And side question, does this seem more like the process you go through when you're writing code? Jumping around, suddenly double guessing the things you wrote down and changing it. This is more a typical process, but usually I avoid this in the classroom because we're very restricted for time. Even on one method here, it's kind of stretching out a little ways, right? I was hoping to have this done in 3 more minutes, and I just thought of something that would almost completely revamp it. Well, the text box is coming as an input, so probably the output's doing the same thing. Where are the outputs? Yeah, I'm just going to use that label with instructions to change that back. Oh wait, those would be different. I guess I need some outputs. Oh wait, we don't have any outputs. So where's some labels? So I'm going to copy this label and paste it on here. And I'll just change it to say out. And start it with a blank string. Oh, that's not blank. Okay, then it needs to go on here. So I copied, a lot of copy and pasting. Okay, computers never make typos, that's a human process. Of out and fix that. Which goes in at Becky. This goes in at Sally. So copied and pasted it. It would have been nice to run the first one, but I have to get these on here before I can do the next check. And hopefully this seems a lot more like what you're used to when you start putting your programs together, right? Output grid. Let's say row equals 2, column equals 0, add x equals 10, add y equals 18. Then I'll do a shift home to select that, then copy that line and paste it in here, where it becomes Sally out and move. Oh, still has the same position in her tab. So the only thing that needs changed is the original name here. That's it, wait. What did I just do? Oh. Yeah, that's why I often find myself working in a regular text editor that doesn't have all those fancy features. This boxes will pop up in your way suddenly, and you might accidentally click on stuff and make changes without knowing what's going on. So now there's outputs for those. So I want a list of those. Again, I'm just going to say array. I think everybody knows the difference between a list and an array here. It's a technicality that we don't have arrays in Python, but it fits better with some terminology. And use parallel arrays. There are multiple arrays, but everything's lined up, sequenced the same in all of them, so that we can refer to all of them with the same index and just have to keep track that Bob is the first one. Sally's the second one. And Becky's the third one. And then we can just refer to everything in that array with a loop so that it's set to grow. And then actually refer to anything, we're going to do it one at a time. But if we need more, we just add stuff to our list. So then as we're walking through, all our arrays are the same size. So that index is going to be you just have to check how long one of them is, and we have to use that same index everywhere. We have the stuff for the input, then the calculation, and then we'll come down and output that. So the employee output array, whatever index we're currently working in, well, that's only holding TK widgets. I almost went back and changed this one to put those text widgets in there, but I decided just to keep it like it was, maybe in part to show the difference. Well, that's all a bunch of labels, so we can refer to those by the text key that refers to an attribute of something that's a child of a dictionary. It's several classes, child classes later of inheritance, but it's it comes down from a dictionary, so we have keys to refer to our attributes, such as the text attribute. And that one we're currently looking at then gets our gross pay value. So quite a bit there. Took 2 minutes longer than I wanted to. I tried to restrict it to 20 minutes because, well, y'all know that gets carried away. But hopefully that was a little bit more like how it goes when you put software together, right? There's a lot of jumping back and forth, changing your mind along the way, backtracking. I usually do that stuff at home before class so that we don't waste the short amount of time we have here. But I always like to do it in class too. That one wasn't completely off the top of my mind because I did know where I wanted to end at. I knew the spot I wanted to end at, so I wasn't completely making that up. But in a little while, actually probably Thursday, those two lines there, along with that other array above, I'm just going to use that term. But please remember I'm slipping away from the technicality to the normal conversational version of that word. Those three arrays are going to segue into the next topic after we finish the GUI stuff. And before we go back to look at more classes. So I think that might work. Let me give it a try. And remember, if you're somewhere where you can, it's a good idea to restart the kernel, the interpreter you're using itself. Sometimes like extra images will add up and stuff. Oh wow, it didn't automatically crash. So I put a 32 in here and hit the button. It's supposed to call that. I don't see an output. String object has it is numeric. We'll try that. Oh, that button doesn't do anything yet. Well, it got a couple lines further. Okay, sorry. That method is called isNumeric. In JavaScript, it's called isNumber. IsFloat. IsInt. There's a bunch of them in JavaScript. That was what I was thinking of. I'm pretty sure that's what I was thinking of. It's a lot of languages, they run together sometimes. In Python, we want the isNumeric to see if something's a number. But it got down here somewhere and did not know what employee we were talking about. all these things that said employee originally. I'm going to copy on the S so that it's the employees array and then the index for the array. So just some very, some copying and pasting, oops, fixing typos. You all know how typos go. So normal process of change the things you don't know, or the things you know do not work, and test again. Oh, no error message. The number showed up like it was supposed to. What's on the other tabs? Should be 0, right? Becky's showed something, but she's on a salary. So it doesn't matter how many hours she worked. If she worked 1 hour this week, or if she worked 80 hours this week, she gets her salary. So those two tests are appropriate. If we run back and say, maybe Sally worked 23 hours, click our button again, that works. Bob's thing's there, Becky's thing's there. There's multiple ways to format a string. Yeah, we'll come back and format strings. We're talking about GUIs right now, so formatting that string to look like money would be an easy change. So now we just need the rest of our stuff to run that same method. Now that it works once, we copy and paste. There's a whole lot of that in our GUIs and event-driven programming stuff. So the toolbar. So there's the menu. There's the toolbar. I'm going to go ahead and use a Python. We could do it the same way we did in the menu. The button does have a command thing, but not all of our widgets have a command thing. And we also have some control over things that aren't even related to the widgets, like the keyboard. So our other way of doing that, which often works with buttons, this was an early experiment. The command attribute was an early experiment that did not carry through to all the things that were modeled after the TK interface. But it's still available in some things in the TK interface package, so we can use it. Button has it. I can go ahead and do a binding just to have more examples of those because we're more likely to use those. We have more things that we can just bind. So any of our widgets have this method built in called bind. And you can see there on the predicted list, we need a sequence, a function, and add for additional arguments. There are some other things, the other things we want to pass into our function. And our bindings always look like this. So when we call that bind method, the first part's a string, and we want to bind a listener to this method. Remember when we were talking about it during programming, we talked about we have listeners that just sit there and wait for the computer to detect something. And the whole process of that is the operating system gets what's called interrupts. This is also in that video that I made. A hardware interrupt. A user always gets priority. So when I come over here and push the angle bracket key, that takes priority over everything else the computer was doing. That's called a hardware interrupt. Same thing with a click or anything else that I would do. Or sometimes right behind the user or automated processes that need to happen. So like timers will go off and preset things need to happen. So those are right behind the user, or the user can sometimes set timers as well. And the user timers fall right below the user hardware interrupts. We're going to interrupt whatever software was running because the human gets priority with the computer. So the computer takes that interrupt and pauses what it's doing, collects all the information about it, like on a mouse click, it's like, okay, a mouse click happened at these XY coordinates on the screen with this timestamp. And if it was a touch screen, it would include the pressure it was touched with and the general vicinity, any movement that happened there. A whole lot of information is the operating system grabs every bit of information it can about what interrupted it. It's a key press, what key was pressed, how long was it pressed for, all that stuff. And then it passes that to the software currently running. It's like, okay, something happened at this timestamp. So what software was running there? So then all the software running on the computer at that particular time, right? So if I come down here and open the task manager, I'm pretty sure everybody's, can I do this one? There we go. Apparently I can't right click in the taskbar to get task manager anymore. So I'm gonna have to look at where that is on Windows. But everybody's already aware of that, right? But when I push the Control-Alt-Delete key right there, all of this software is running. So the computer, the operating system would have been like, oh, there was a keyboard interrupt, puts all of this stuff on pause. It's like the user wants to do something. Who needs to be listening for this Control-Alt-Delete key? In that example, the operating system itself would. But then something would respond. Or who needs to be listening for a mouse click at a certain spot? And then that's how those are the listeners. So those listeners, when the operating system detects an interrupt, all the software needs to know what it's listening for. So for a button click, we want to listen for button 1. That was a lot of words to say type button 1 there with a capital B and a dash. So trying to be somewhat thorough and help develop that understanding of what's going on, how these things interact with each other. Because as your software gets more and more complicated, you're gonna have to do more and more stuff with that interaction. We are very restricted for time in the classroom. So the classroom stuff is usually planned well in advance for things that fit in our time constraints. In the world at large, after you graduate, you will immediately jump into much more complex problems that you dealt with. Hopefully y'all can kind of foresee that, right? In the classroom, we're very restricted for time, so we have to do things that cover a lot of stuff in the time we have. But then when we graduate and move into the real world, we need to be working on the current problems in the field, which are much more complex than anything we cover in a classroom. So it's like we're progressing slowly through our classes, and then when we graduate, it's like a jump up. It's not a different thing. It's still software development. So what you learn in the classroom applies directly. But at first, it might take you as a surprise, that initial jump. I know it did me. After all this stuff in classrooms and then start developing software for actual companies, it's like, oh, this is a big jump from what I was doing a couple weeks ago. It's not a different field. It's not anything complicated, but it's more. There's much more of it. But we get paid by the hour at that point. So more stuff to do is kind of nice when you get paid by the hour. So please don't take that as like a warning or a bad thing. It means there's lots of hours to work. But if you get paid by the hour, you get a paycheck for all those. So now back to this. Once we have the thing we're listening for, what do we want to do? So we want to wait for that event. So that's that lambda, we talked about that already. So we're going to wait for whatever we're listening for, because we might need to pass in some parameters. In this case, I don't think we actually need to pass any in, but I'm going to go ahead and do the wait thing anyway. And then we'll call the gross pay method with that event. So all of our bindings look like that, follow that same process. The thing we're listening for, and then usually it's a good idea to do a lambda and the event, and then if at some point later you need to add some had some other arguments to throw in there. You'll already be set up to add more stuff later. Then down here, we can do that every time we hit the enter key. We don't want to apply the enter key to a particular GUI. We could do that. I set it up so that we're just calculating everything. We're going to do one at a time. We could bind that txt bob dot bind to the enter key. I'm just going to bind the overall software to the enter key. The only thing that would change is I call the overall piece of software graphical user interface GUI. But if you wanted to bind it to just the text box as focus, you could just do say like txt bob. Bind that one to the enter key. And then that listener will only react when it hears the enter key and that text box has focus. So if we were to bind that key press to a particular widget, that widget has to have focus. So like we just finished typing something and then hit enter with our cursor still there. That would probably be a better method for this format, but I'm just going to type to the overall binding, so the only thing that will change is this first part. So when that happens, we can just call our method. Again, we'll wait for the event and then call the gross pay method and pass in that event. So hopefully you see there, if you haven't done bindings before, the similarity between the key press here and the button press. There we go. Get them where they're both on the same line at the same time. So from line 71 and line 95, hopefully you can see everything they have in common. Then there's a list of things, so we can push like Control Shift H. The thing to remember, I'll put it in the comment because it's not really here. If we do that, I want to just say like Control Shift H versus Control H. The Shift key would change us to a capital H, right? So with the PK interface package, you do have to watch that capitalization. So if it's Control key press, you want a lowercase e. If it's Control, or if there's a Shift key press, you want to make sure to do the uppercase letter. So now those other buttons should work. So we enter Bob's hours and say he worked 45 hours. Hit enter. We get his number show up. We go over to Sally's. Maybe she worked 34 hours. Hit the payroll button. That worked. Becky's. So looks like that's working. Hopefully that wasn't too confusing. But then there's one other thing to consider. Oh, let me run that again. I'm going to pull out my notes from the Monday Wednesday class because I have something wrote down here to remind you all about for those who heard it and introduce it for those who did not. It was a couple weeks ago. So we're here studying software development, right? But obviously that's not the only degree we'll find at a college. Just down the hall from where I'm at here in Ogle Hall is the graphic design students, visual communication department. They're just right down the hall from the IT department. And they're studying something a little different. They're studying design. So there's some words that we want to keep in mind because, well, artists have studied things very carefully as well. We know how things affect people. And there's 4 key principles of design that if we're working on a front end, we might want to keep in mind. Anytime we're putting together the interface the user is going to work with. Specifically, did not add this to this class notes and pulled it out of the SDEV 153 class notes, but a similar thing. We're designing a graphical image sort of interface for user to work with. So we want to keep the principles of design in mind. So the first one is repetition. Which is tie things together by repeating patterns. I'll go ahead and write them all out. So repetition. Group things that should be grouped together by repeating similar patterns. Right? If your GUI has multiple tasks, because in this case we're talking about usage. Right? We want the user to open up our software and almost feel like they know how to use it immediately, or at least be able to feel like they're going to figure it out very, very quickly, so that they're not going to move to another piece of software. When we talked about this in the HTML class, those who are in there, we were talking about this in terms of colors and layout, colors and fonts and stuff. But the same principles apply here, only for ease of use issues. So repetition, repeat patterns so that the users can find their way around. Contrast. That's make important things stand out. Three is proximity. Which is group related things. That does not look like the letter H. Group related things. And the fourth key principle of design, this is what your visual communication peers study through their out their degree. This is the things they're focusing on, but it does apply to us as software developers as well, in more than one place. Several of y'all saw me go over these in terms of colors and white space, colors and empty space, I guess. And finally, alignment. Organize sections relative to each other. So this isn't a graphic design course, so I'm not really going to go into it much more than listing out the 4 most important things in graphic design, because we do have a visual thing going on here. So we want to at least do a quick comparison on what we did to these 4 concepts: repetition, contrast, proximity, and alignment. So after you get your GUI together, you want to ask those questions. How does my layout for a GUI stack up against the key principles of design that have been thoroughly studied by very smart people that really like art and psychology and want to tie art and psychology together for the various reasons that those two fields would be tied together? How does it affect people? So I go back here. First off is repetition. Tie things together that go together. Well, our menu is kind of trivial, but if it wasn't a trivial example, there would be that main menu that categorizes it, everything the software can do. So everything's tied together up there in that. Then when we hit the drop-down menu, things would be tied together with that. Kind of more like this. I'll point to this one, an actual finished full menu. There's repeating patterns, right? Like up at the top, there's our new stuff. And then, well, there's actually a separator item. That's just tk.separator. We create it like we would a button or any other menu item. Add underscore separator in tk. Just like you do add underscore command. Then the open stuff. And then we repeat that pattern again of all the save stuff. Then all the print menus and all the close commands. I should be using that word. Then file switcher and symbol finder, whatever those commands are. Then the restart and log off commands. All that stuff's grouped together by repetition. So our example is trivial, but that's what the menu does that. Not just the menu, the toolbar does that. We only have one button. Then we have the toolbar that does everything that does. It also stands in contrast to everything else, right? Toolbar's got a bunch of pictures to help identify what it does, so that we can do that when we're half asleep and zoning out because we've been sitting and working way too long. You look at those pictures and don't have to think about it. Don't have to think about the words. You know what the pictures mean. So contrast to make things stand out. Repetition. It's the button style controls. So all of them are grouped together. We have that proximity one. Alignment. It's a toolbar in this case, so it just kind of goes straight across. Everything's in a nice little line there. I tried to apply these concepts down here with what I was thinking for the primary and out. Our example is stripped down and trivial so that it could fit in our time constraints, but this is America. And, we all have to work, and so we can afford to buy food and have a place to live and all of that good stuff. So that's part of the reason I picked this example is that hopefully you all can picture this expanded because you kind of know what it's like. So whatever we did would have had to been stripped down. And I thought this might be the easiest one to picture being filled out. So for repetition, it's the same layout, right? When I copied and pasted that grid part, I didn't have to change any of the row numbers or column numbers or padding. I wanted every single one of them to look the same, so there's that repetition. Whoops, this icon. It repeats across all our different tabs. For contrast, the tabs kind of have white space. They're spread out. It's stretched out. It's not all pressed together. Lots of white space so that it doesn't seem as drastic when it expands. You go in there and edit that file, take out all the padding, and then get that maximize and minimize button. And you'll notice a subtle difference. You'll notice the difference there. If you have a lot of white space, that subtle thing that's hard to put into words when all the stuff's crammed together So it's like your GUI when you suddenly make it full screen, but all that stuff's so crammed together. Has a subtle effect that's hard to put into words. But white space really helps with that one. I've always grouped it under contrast. Somehow the white space contrasts the stuff. Proximity, that's the tabs. They're grouped together. Alignment, the sections relative to, organized sections relative to each other. So each employee gets their own section. So we want to keep those four things in mind: repetition, contrast, proximity, and alignment. For those who saw me, had me on the Monday, Wednesday class this time, when we talked about that not long ago, we were talking about colors and sizes and stuff. But in this case, those same four words and definitions, I wrote it word for word off the same set of notes both times. The same set of four words and definitions apply to the ease of use. When a user opens this up and has to figure out how to use this software for the first time, because you know nobody's going to read a user manual. Nobody reads a user manual until we get stuck. That's something we know about humans, so we need to think about it ahead of time if we know it's going to happen. But other people might feel differently about it. So we can change that. And, okay, so maybe I don't like it. And that's something you're often going to want to do. So another thing I'm going to do, we'll go over to the file explorer here, grab this, copy that, and paste it. Nope, Control C doesn't work there. I hope I didn't copy and paste something else. Copy, paste. There we go. So now I have two of them. Now, there's always a chance that the person that's wanting this made isn't going to like that layout. The functionality the customer would have asked for, right? Customer asked for functionality, but they might not have told us the layout. So we could keep this stuff in mind, put one together. And without changing the functionality here, we could probably command the copy, but make sure you're working in the copy. I'm going to go ahead and close the original because it works. We already tested it. Restart the kernel, make sure it's all closed and everything. Maybe they don't want those tabs. I'm gonna take out everything that relates to that tab here. And I'll just put them all in the same on the same page. So Bob gets column 0. Then I'll move Sally's stuff over to column 1. And Becky's stuff over to column 2. Right. Oh, NB main is not defined. So I'm going to take that out. Oh, wait, actually, I need a place to put those. So I'll make a frame. Instead of a notebook, I'll just use a frame. I'll go back to that original word. IO primary. I couldn't think of a word quick enough. It's going to be a frame sitting in our main GUI. That's all stuff we've seen before. Now I'll define and replace NB main with IO primary. Place all those. That should be good. Give it a try. Oh, this is why you want to be able to restart your kernel. Sometimes it will, the TK package, this happens when debugging. So once you're finished debugging, it's not going to happen. When you get an error, that old photo image we use for our button is still loaded into memory. So then when it tries to load another one, it tries to create too many and then it cleans up the references. Python has really, really good garbage collection, keeping memory as efficient as it can along the way. So it'll sometimes clean it up too much. So when debugging, you want to crash this. That stuff shouldn't happen in release, except when certain errors happen. Oh, PK.frame. So just the normal sort of typos that happen. And once again, it lost track of images. Oh, there we go. There's all the stuff I was expecting it to show up here. Take out this stuff and look at the code to figure out where that went wrong. Missed a line somewhere in there. So we fill that in. Then we put all this stuff in as grids. Oh, those tabs need to go in. So actually, I can change this back to what it was. All right, I'm gonna do this. So the earlier one, each one of those notebooks had their own frame. So I'm going to get rid of that frame. And then change the parent object for every single widget here. Paste, paste. So a whole bunch of copy and paste. Y'all know how that goes, right? An alternative to get the same results is everything was already put in a frame. I could just leave that as a small frame and then kept it with the original column number for that frame and load in all three each frame in its own column. I think y'all are well aware of that. There's more than one way to do everything, right? So we can see that it still works the same. Put in our numbers, hit our buttons, it calculates the pay. Oh, that's a typo. 67 hours is a lot, so maybe 27 hours. Check our button. That still works the same. 33 hours. Check our other button. And that's something else you're going to want to do. Notice the menu, the toolbar, the status bar. We never did change that. That's just changing labels. We call that somewhere. Oh, after we do that, I'll call update status method and say pass in the event just in case something happened and say updated everybody's gross pay. And then, or an appropriate message for whatever it is. That way it updates whenever we do stuff. So we already had the method there. We just didn't actually call it and use it. But now if we kind of update some hours, hit the enter key, that works. Enter this person's hours, 42 hours. Our toolbar button. So that stuff that's consistent, main menu, the toolbar, the status bar, those are still the same, but our user may want something different. So it's really quick to swap out a different main section. So that's something else you're going to want to do in the long run. Definitely something there's probably not time for in a classroom, And you don't want to make a bunch of versions, but when you start making things for clients, make different versions to see which one's better. Or if you start making stuff as part of a team, or if you're just doing freelance, completely making stuff yourself, make some alternatives. Because then you can run both of them and see which one you like, side by side. And minimize this, I go over here. I'm gonna go to where this is located. In this folder, I'll run that one. I'll come over here and run this one. And now, do a side-by-side comparison between them. Kind of see which one, like the appearance of better. That's another thing you're going to want to do, which we definitely don't have time for in the classroom. Especially when it comes to GUIs. I guess it's not really going to show up much in console stuff in the background. But make alternate versions, and for a GUI, that's just going to be your alternate primary I/O area. I never have come up with a good name. I just thought of that one a couple weeks ago. So I've also called main content area, working area. I don't have a good name. I haven't come up with a good name for that section. But the section where the main part of the GUI. That's all that's going to change for alternate versions. So once you get it working, and swap it out for alternate versions and kind of do a side-by-side comparison, see which ones you like. So now just to kind of do a quick wrap up. It's set up so that everything's done in arrays. I'm going to go ahead and use that word. In parallel arrays. So if we had another employee, we could just add them to the array here. Then add them to the array here. And add them to the array here. Very similar to this. If you're wondering if we could just create an array of labels generically, yes, we can. That's no problem. It should be an easy thing. That would be a good thing to try tonight in lab. So you can switch it out from having those specific versions to just completely having it in an array where you never need a name for it. It's just tracked by an index. Because the next thing I want to look at, which is going to happen in a couple of days, has to do with these parallel arrays. When we increase that or automate that or build that up in general, it'd be really nice to have an automated process to deal with that array. Because that number we want, the stuff we want to put there, in a real situation would probably be over in the database, right? When we're building our software, we don't know how many employees a company has or what their names are or anything like that. But we can be fairly certain that there's a company database that has that information. So it'd be nice if we could just look at that database and put our list together. That's the next thing I want to look at. We'll see that on Wednesday because there's still some things you could open up this example. If I throw it on GitHub real quick, you can download this example and make some changes. Like get rid of these explicitly named things and just make them part of another parallel array. Currently an array with 3 things, and each thing has a label, entry box, input, an instruction label, an input box, and an output label. That could easily be put into an array and kept track of. A list of lists, and each list has 3 widgets in it, if that makes sense. That's going to be my recommendation for lab time tonight. So I'm going to throw this on GitHub so you can grab this file and do that if you want to give that a try. pretty stuff. I think I ended that sentence at a different place than I started it, a different thought than I started it, but it's not doesn't have to be grammatically correct. It just has to identify this particular commit. Git push or we've seen all that stuff. Okay, so that file's on the class GitHub example stuff. If you want to download that, mess around with that. Try some different layouts. I did 2 there. Maybe that would just be a good idea. Go give it, change out that primary and out section for different ways that could be laid out. Maybe a radio button or checkbox for which employees you want to calculate stuff for, or different types of widgets, and just kind of play around with that. We've got about 20 minutes left in class. That's my suggestion, and one of those 2 suggestions, play around with that GUI, come up with some alternative ways for that one. Just a quick change out like we did there, and make sure you ask those 4 questions from the, ask yourself if it matches the 4 key principles of design, or try swapping out those specifically explicitly named widgets for the input there with a arbitrary array of input widgets that would behave in exactly the same way. Otherwise, does anybody have any questions for this evening? Okay, I assume the science means no questions. The very next thing is that what that was a segue to. How do we automatically generate those lists? Everything we've seen before, and every example in our textbook, we explicitly fill out a list. How do we generate it if we just know that stuff's in a database somewhere else? We will start with that on Thursday. So y'all have a great evening. I'll see you on Thursday. Let me know if you have any questions.